Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Calculus series and concerns integration and natural logarithms. This guide describes an extremely useful substitution to help you integrate certain functions to give a natural logarithmic function. It describes a pattern you should learn to recognise and how to use it effectively. Introduction. One of the main differences between differentiation and integration is that in differentiation the rules are clear-cut. In differentiation, if you know how a complicated function is made, then you can choose an appropriate rule to differentiate it. See study guides, more complicated functions, differentiating y equals ax to the n, differentiating basic functions, the chain rule, the product rule and the quotient rule. This is not true for integration. Although it is important that you learn how to integrate basic functions, see study guides integrating y equals ax to the n and integrating basic functions, beyond this there are many different methods for integration which you should learn. Integrating more complicated functions becomes a matter of looking carefully at the integral you need to perform and trying a relevant method. Many of these methods involve recognising a pattern within an integral. One very common pattern you should be aware of is the following. The integral of f' of x divided by f of x with respect to x equals the natural logarithm of f of x plus c, where f' of x is used to denote the derivative of the function f of x. Here the integrand, i.e. the piece of mathematics you are integrating, is a fraction where the numerator is precisely the derivative of the denominator. Because of this, you need an understanding of differentiation to use this rule correctly. If your integral takes this form, then the answer is the natural logarithm of the denominator. This integral plays an important role in science, and it appears, for example, in exponential decay and growth and first order rate kinetics. A special case of this integral is well known. When f of x equals x, the integral of 1 over x with respect to x equals the natural logarithm of x plus c. This integral fits the pattern, with f of x equal x and its derivative f' of x equal to 1. Example. What is the integral of 5 divided by 5x minus 2 with respect to x? The question can be written mathematically as the integral of 5 divided by 5x minus 2 with respect to x. This integral looks difficult, but it fits the pattern on the first page of this guide, as the derivative of the denominator, f of x equals 5x minus 2, is equal to the numerator, 5. So, the integral of 5 divided by 5x minus 2 dx equals the natural logarithm of 5x minus 2 plus c. You can check this result by using the chain rule to differentiate the answer. Example. What is the integral of 2x plus 3 divided by x squared plus 3x plus 3 with respect to x? The question can be written mathematically as the integral of 2x plus 3 divided by x squared plus 3x plus 3 dx. The integral looks complicated until you recognise that it fits the pattern on the first page of this guide, as the derivative of the denominator, f of x equals x squared plus 3x plus 3, is 2x plus 3. So, the integral of 2x plus 3 divided by x squared plus 3x plus 3 dx equals the natural logarithm of x squared plus 3x plus 3 plus c. Again, you can check this result by using the chain rule to differentiate the answer. Example. What is the integral of minus tan x with respect to x? The question can be written mathematically as the integral of minus tan x with respect to x. Often the pattern on the first page of this guide is hidden by other mathematics. Here, you can use the trigonometric identity tan x equals sin x divided by cos x to show that the integral of minus tan x dx equals the integral of minus sine x divided by cos x dx. Applying this trigonometric identity means you can re-express the integral with the derivative of the denominator f of x equals cos x being the numerator minus sine x. So the integral of minus tan x dx equals the integral of minus sine x divided by cos x dx, which equals the natural logarithm of cos x plus c. Again, you can check this result by using the chain rule to differentiate the answer. Using a constant to adjust the integral. In order to use the pattern on the first page of this guide, the numerator must strictly be the derivative of the denominator. However, you can adjust the numerator of the integrand to help it fit the pattern. The only way you can adjust the numerator is by multiplication or division by a constant. You cannot add or subtract a constant to the numerator. You also cannot manipulate the numerator by using a variable, i.e. you cannot add or subtract a variable, and you cannot multiply or divide by a variable, for example x. In summary, you are allowed to multiply the numerator by a constant, to divide the numerator by a constant. What is not allowed is adding or subtracting a constant or variable to the numerator, multiplying or dividing the numerator by a variable. If you need to adjust the numerator of the integrand, then you must ensure that you do not affect the overall integral. For example, if you multiply the numerator of the integrand by a constant, then you must divide the integral by the same constant. The multiplication and division cancel each other and you essentially do nothing to the integral. Similarly, if you divide the numerator of the integrand by a constant, then you must multiply the integral by the same constant. This is best illustrated by an example. Example: what is the integral of x divided by x squared plus 7 with respect to x? The question can be written mathematically as the integral of x divided by x squared plus 7 dx. The derivative of the denominator, x squared plus 7, is 2x, but you have a numerator of x. If you multiply the integrand by 2, then the integral will fit the pattern on page 1. The integral of x divided by x squared plus 7 dx. If you multiply the integrand by 2, you get the integral of 2x divided by x squared plus 7 dx. However, you cannot make this adjustment on its own, as you will change the integral by a factor of 2, i.e. you have altered the integral you are performing. However, if you also divide the integral by 2, then you have made no overall change to your integral. The integral of x divided by x squared plus 7 dx. If you multiply by 2 and divide by 2, you get 1/2 of the integral 2x divided by x squared plus 7 dx. The integrand now fits the pattern on page 1, so the integral of x divided by x squared plus 7 dx equals 1/2 multiplied by the integral of 2x divided by x squared plus 7 dx, which equals 1/2 multiplied by the natural logarithm of x squared plus 7 plus c. You should note that the divide by 2, the half, is carried forward into the answer. You can check this result by using the chain rule to differentiate the answer. Example: what is the integral of x squared minus 2 divided by 6x minus x cubed with respect to x? The question can be written mathematically as the integral of x squared minus 2 divided by 6x minus x cubed dx. The derivative of the denominator is 6 minus 3x squared, which is the numerator multiplied by minus 3. It is very common to change a sign in the numerator by multiplying by minus 1. So, the integral of x squared minus 2 divided by 6x minus x cubed dx multiplied by minus 3 and divided by minus 3 becomes minus 1/3 multiplied by 6 minus 3x squared divided by 6 minus x cubed. The integrand now fits the pattern on page 1, and so the integral of x squared minus 2 divided by 6x minus x cubed dx equals minus a third multiplied by 6 minus 3x squared divided by 6x minus x cubed dx, which equals minus a third multiplied by the natural logarithm of 6x minus x cubed plus c. You can check this result by using the chain rule to differentiate the answer. Further guidance and information. If you have any further questions about calculus or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. Telephone 01603 592761. Email dos.help@uea.ac.uk or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of calculus, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.